In this lesson, we'll be solving a question paper based on arithmetic as well as quadratic sequences. So let's start with 2.1. 7x, y, negative 11 is an arithmetic sequence. Determine the values of x and y. So now the sequence is given as 7x, y, and negative 11. So now we know that an arithmetic sequence has the only first differences. So we're going to determine the first differences. We're going to say that t2 minus t1, that is x minus 7. We're going to say that t3 minus t2, that is y minus x. And we're going to say that t4 minus t3, that is negative 11 minus y. And what we know is that the first differences must be the same. This means that we're going to say that x minus 7 is equal to y minus x, and it's also equal to negative 11 minus y. So let's start. We're going to say that x minus 7 is equal to y minus x. We're going to make y the subject by taking the minus x on the right side to the left hand side. This means that 2x minus 7 is equal to y, and this is the first equation. Again, we're going to say that y minus x is equal to negative 11 minus y. Let's write it. Y minus x is equal to negative 11 minus y. So we're going to make x the subject by taking all the terms on the right side to the left side, and by taking the minus x on the left side to the right side. We're going to have y plus 11 is equal to x. What is y plus y? That gives us 2y. 2y plus 11 is equal to x, and that gives us the second equation. So now, in this regard, we are forced to use the method of substitution. What does this mean? Equation 2 is given as 2y plus 11 is equal to x. This means that in the first equation, where we see x, we're going to plug 2y plus 11. So we're going to say that plug equation number 2 in equation number 1. Then we're going to say that 2, where we see x, we're going to plug 2y plus 11 minus 7 is equal to y. What is 2 times 2y? That gives us 4y. 2 times 11, that gives us 22. Minus 7 is equal to y. Let's take the y on the right side to the left side and say that 4y minus y. What is 22 plus minus 7? That gives us positive 15. Then is equal to 0. What is 4y minus y? This gives us 3y. 3y plus 15 is equal to 0. We can take the positive 15 to the right side and it changes the sign. 3y is equal to negative 15. We divide both sides by 3, and y is equal to negative 5. So now we have solved for y. We're going to go back to either the second equation or the first equation. Then let's plug in the second equation. So we're going to say that the second equation was given as 2y plus 11 is equal to x. But because we have solved for y, we can now solve for x. We say that 2, where we see 1, y, we're going to plug minus 5. And plus 11 is equal to x. If you plug all that on the calculator, you will get 1. This means that 1 is equal to x. At the end, you can say that therefore, x is equal to 1 and y is equal to minus 5. I hope you understand that. Let's go to the second question, that is 2.2. First, let's erase here. So now, in 2.2, we will skip 2.2.3 and 2.2.4 since they are not based on what we have done. So, 2.2 says we have been given the sequence -3, 6, 27, as well as 60. So, 2.2.1 says determine the general term for the pattern in the form Tn equal to an squared plus bn plus c. Remember, we've said if an examiner doesn't say general term, he will say nth term, or he will say the defining equation of the pattern. So we're going to say that to get the value of a, we must first know the second differences. The basic form is that Tn is equal to an squared plus bn plus c, and we always start by solving for a. So let's write our sequence here nicely. That's -3, 6, 27, followed by 60. So we're going to come with the first differences before we go to the second differences. The first differences, we're going to say that 6 minus -3, that gives us 9. 27 minus 6, let's see, 27 minus 6, that gives us 21. And 60 minus 27, that gives us 33. And these are our first differences. These are our first differences. So we're going to come with the second differences from the first differences. We're going to say that 21 minus 9 gives us 12. And we know that 33 minus 21 must give us 12 as well, since we have said that the second differences of a quadratic sequence are constant. On the second difference, we say 2a. On the first differences, we're going to say 3a plus b. And on the given sequence, we're going to say a plus b plus c. So we're going to start by solving for a. We know that 2a is equal to the second difference, that is 12. By dividing both sides by 2, we'll end up with a being equal to 6. Again, we know that 3a plus b is equal to the first term of the first differences, that is 9. This means that 3 times 6 plus b is equal to 9. Let's check down the page. So we're going to say that 3 times 6 gives us 18. And 18 plus b is equal to 9. Therefore, b is equal to 9 minus 18. b is equal to 9 minus 18 is given by -9. I hope you understand it. And now we're going to solve for c. We know that a plus b plus c is equal to the first term in the given sequence. The first term in the given sequence is given by -3. This means that a plus b plus c is equal to -3. What is the value of a? That is 6. What is the value of b? That is -9. And plus c is equal to -3. 6 minus 9 is equal to -3. -3 plus c is equal to -3. This means that c is equal to -3 plus 3, and that gives us 0. So we have solved for a, for b, as well as c. We're going to plug the values in the formula. This means that Tn is equal to a is given as 6n squared, b is -9, so it will be -9n, and c is 0. We can leave it like this. This is the equation, or rather the general term for the pattern. They said in the form Tn equal to. 2.2.2 says calculate the 50th term of the pattern. What does this mean? We are looking for T50. That is 2.2.2. So for 2.2.2, we're going to look for T50, and we're looking for the value. The value is Tn, and the position is n. So when we see n, we're going to plug 50. This means that we're going to say 6 multiplied by 50 all squared minus 9 times 50. And let's see what we get. It's gonna be 6 multiplied by 50 all squared minus 9 times 50. And we get 14550. This is all for this video. We'll be leaving out 2.2.3 and 2.2.4, but we will touch them at a later stage. Thank you for watching.